Life as we know right now, impossible on Mars. But what if Mars were more like Earth? The now former chief scientist at NASA, James Green, says it could be possible to terraform Mars, meaning make it livable for people, which of course conjures up scenes from The Martian when Matt Damon's character, a botanist, gets stuck on Mars and has to figure out how to survive.
So I got to make water and grow food on a planet where nothing grows.
I am the greatest botanist on this planet.
Joining us now to discuss is an astrophysicist who worked with Green, Hakeem Oluseyi. To be clear, Hakeem, what James Green is talking about here is using a magnetic shield so that it isn't so difficult for Matt Damon / astronaut Mark Watney to grow potatoes on Mars. Explain how this would work.
Yeah, so what Jim is doing here is solving a few of the problems associated with Mars. So one thing about planetary atmospheres, whether you're talking about Mars or the Earth, there is a balance in the atmosphere's mass. They lose mass, typically due to erosion from sunlight, but the atmospheres also gain mass. On Earth, it's from volcanoes, but it basically comes out of the ground. So you have a system where air is leaving and air is coming in. So what Jim proposes to do is to cut off the source of erosion. So what you can do is, between Mars and the sun, between any planet and the sun, there's a low point in the gravitational field that you can orbit that's directly in the line between them. So if you put a spacecraft there and you have a big magnetic field, then it can deflect that solar wind away from the planet, and that way you stop the erosion. So once you stop the erosion, the atmosphere begins to gain mass. And when the pressure of the gas increases, it becomes hotter. So he solves the problem of Mars being too cold, and he also solves the problem of getting rid of a lot of the radiation that reaches the surface.
So, Professor, I'm a dreamer. I'm a dreamer. I want to believe everything is possible. But what you're describing here is like a giant space shield, like a space visor? What kind of car, how big does the car have to be to have a visor that will block the sun from, shining on Mars?
Well, the devil's in the details because, what you're looking at is what we call the angular size. And so that means that as you move something farther away, the angular size becomes smaller. So here, there's a very specific location where this spacecraft has to be between Mars and the sun. So you have to do the calculation based on that location to determine how much deflection you're actually going to get. But it's like an umbrella for a planet.
Like an umbrella that is one big umbrella. So Jim, as you call him, he says that he's putting together a paper, right? He's putting together a paper to talk about how a magnetic shield would work. He says there's several scenarios for that. He also said, though, it's not going to be well received. Why is that?
Well, because, in some ways, it's a zero-sum game. It really isn't. But in science, you have communities of scientists that get behind particular ideas that determine where the funding is going to go years in advance. So we call these things a decadal survey. So you come up with your decadal survey and say, oh, here's what we should do for the next decade. Here's our big priorities. And, that determines where money goes. That determines how careers are developed because there are competing ideas. So now he's going to throw his idea into that competition. And it doesn't really fit well anywhere. And, it's a really new idea. It's something that hasn't been done before. And one of the things that we do judge on is technical feasibility. So it doesn't matter what your new idea is when you're a scientist. Typically, when you propose it, your fellow scientists say, no, it's not going to work. You suck.
Your umbrella sucks is what they're going to say, I think.
Yeah, Jim is a proven fact, but the default setting among scientists is skepticism, right? And so you have to prove yourself to everyone, and even when you do prove yourself, they still don't admit you're right. So it's a tough sell.
Professor, this is delightful. I had no idea that terraforming was so controversial. Nor did I have any idea what terraforming was, but that's a separate issue. Professor, thank you so much for being with us.
Thank you for having me.